All right, so that is basically how they got this idea. The number of elements in A times the number of elements in B would be, if you were to find a sample set of both of them together, you'd multiply them together. Okay? So let's go on to example 1B. It says a lottery game is played in some states involving picking 3 digits from 0 to 9. Describe a sample space in this experiment and determine the number of elements in the sample space. So first of all, what I want you to do is I want you to put 3 spaces. Okay? Any of those 3 spaces can have 0 to 9 in it. So how many possibilities do we have with digits? 10. Yep, you're right. So I have 10 possibilities here. 10 possibilities here. 10 possibilities here. So if I multiply those out, I have 10 to the third, or how many possible numbers in my sample space? 1,000. 1,000 combinations in my numbers. Okay, and if I were to describe it in general, it would be S equals, you could say X, Y, and Z, right? Because there's 3 spots. Any questions? Okay, strings. We're not talking about yarn here. We are talking about numbers. It says when the symbols in a problem must be ordered, it is common to refer to the order of the list of the symbols as strings. The number of symbols in the string is the length of the string. Okay? Example. On a 10-question multiple choice math test, each question has 5 choices. How many possible completed answer sheets are there? So, what we have is 10 possible choices. If I have 10 slots, dot, 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 yep, it's going to be 5 to the 10th. Okay, if you were going to actually multiply that out, it is 9,765,625. So this would be choice 1, choice 2, choice 3, all the way up to 10. Huh? If you guess randomly on each question, what is the probability of answering all 29 questions correctly?
There's only 10.
Yeah, I should say 10. This should say 10. Woo, this should say 10. So it'd be 1 over, yep, 5 to the 10.
Why would it be 1 over 5?
Because that's the only one time where they all get all of them right. So if you're just guessing randomly on it, okay? 1 over 9,765,625. Okay? That's purely based on randomness. You guys, it is super hard to be random. I don't know if you know this or not. But if you were, honestly, because your human intuition kicks in and you honestly are not, it's hardly possible for a human to be random. Okay?
Unless you know it and then you just put it on.
That's not random then, though. So that's why you need a machine to honestly pick up random numbers. Okay, number 2B. It says 3 of the questions on the science test are multiple choice with 4 choices each. How many ways are there to answer the questions? 4 to the third, because you have 3 slots, and they each have 4 questions, 4 possible answers. So 4 to the third, which is 64. All right. Below are a few examples of a string for the test question in example 2A. Okay? So how many possible how many answers are there? There's 10, isn't there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 questions with the possibilities. These strings are with replacement. So if you use A again, if you use A, can you use A again? Yeah. That's what it means by with replacement. So A is still an option for the rest of the questions. Okay? It's kind of like if you have a bag full of chips, okay? And you pull out a Ruffles and you don't eat it and you put it back in the bag, that's with replacement. Okay? No one would ever put a Ruffles back in the bag. I guarantee you I would eat my Ruffles. Okay? Okay. Let S be a set of n elements. Then there are n to the k possible strings with replacement of length k with elements of S. That's what we've been doing all up to here, okay? So, here's a different one, though. This is a little bit different. We have a license plate with 2 letters followed by 4 digits, okay? So, yes, we have 6 slots. How many possible letters do we have? 26. So there's 2 letters with 26 possibilities. How many digits do we have? 10. There's 4 slots with 10 possibilities in it. So what you're doing is actually multiplying all these out. So it'd be 26 to the second times 10 to the fourth, which ends up being 175,760,000. Yep, that's just for one state, right. If we were to count how many states, we could put another slot here and put 50, right? 50 possible states, that would make a whole different deal. All right? Okay, I'm going to let you guys think about the next one. By yourself, don't say it out loud, try it on your own. Some states allow license plates with 3 letters followed by 4 digits. Figure it out. At least set it up. All right, so we have 3 letters. Yeah. Pardon me?
You did the answer for 3A, the answer for 3B.
3A is the answer to 3B, and 3A is 6,760,000.
Oh! You're right. So that goes here. This one should have been 6,760,000. Sorry, my eyes went ahead of problem. But anyway, you're going to take 26 for 3 slots. And then 10 for 4, right? So this would have been 26 to the third times 10 to the fourth. Thank you for pointing that out. Okay? Any questions? Okay, so we think of events A and B as independent. All right? The probability of A does not affect the probability of B. So if I pick an A for one of my first 3 slots, it does not affect any of the other slots. Right? Because it's with replacement, so I can always pick it again. Okay? Probability of me picking a 9 over here does not affect any of the slots, so they're independent. All right. So, number 4A. The spinner here is used in a carnival game. It doesn't even show you the spinner, so I'm going to draw it. It looks like this. And you have numbers 1, 2, 3, 4, 5, 6. Okay? It is assumed to be fair. The game consists of 2 spins. You win if the first spin stops on an even number, and the second spin stops on a multiple of 3. What is the probability of winning? So me stopping on an even number, does that affect my second spin at all? No, it doesn't. So they are very independent. Okay? So first I want to look at what is the probability of stopping on an even? 1.5 or 3 out of 6, right? Okay? And what is the possibility of landing on a multiple of 3? Yep. We have 3 and 6, so that'd be 2 out of 6. So what I'm going to do now at this point is multiply straight across. 2 times 1 is what? And 2 times 6. And then I can reduce that 1/6. Yes.
Wait, why do you have divided by even divided by 1?
Because the first question was, what is the probability of landing on an even number? So there's 1, 2, 3 even numbers in that.
No, why do you have, well, are you dividing the half by another even number? Or
No, because 3 out of 6 is,
No, is that like just a label?
yeah, it's just a label.
Oh, okay.
Just a label. And then this is a multiple of 3, that's my label. Okay? 4b says, in a certain spinning wheel, there are 20 sectors of equal size. In 18 of these sectors, you win a prize. But in the other 2, you lose all your winnings. If the wheel spins randomly, what is the probability of winning 5 prizes then losing on the 6th spin? So, we have 5 slots of winning. Okay? 18 out of 20. I'm going to multiply that 5 times, right?
Can't you do quantities?
Yep.
Quantities.
To the 5th power. Yes. You can do it to the 5th power. She's asking if you can say 18 over 20 to the 5th power. You can do that. Okay? And then what is my last spin? What's my possible 2 out of 20, right? Okay, so then I'm going to multiply that by 2 out of 20. So the probability of actually this happening, and then if you put it in decimal form, it's going to be 0.059 is what I got.
5%.
Yep. Or 6% really, right?
That's the answer.
Mm-hmm. All right. Now, events that are not independent are called dependent. You guys are so good at deduction. So, the spinner here is used in a carnival game. It is assumed to be fair. The game consists of 2 spins. You win if the first stops on an even number and the sum of both spins is greater than 8. It says, show that the 2 events are dependent. And I'm going to assume that we are using the same spinner we did before, 1 through 6. Okay? Okay. So it says, first of all, I want to see what are my possibilities for spin 1.
1/2.
Yeah, 1/2. But what are the various ones I could have? I could have 2, 4, and 6. I'm just writing out my possibilities. It has to end on a 2, 4, or 6. Okay. Spin 2, knowing that I have 2, 4, or 6 I'm starting with. Uh-oh. I hate it when it does that. Hold on a second.
Why does it have?
Okay, so spin 2,
Did you go home or
I can have a 3 and a 6. So starting
you
off.
have to use everything?
Yep,
Oh.
everything. I can have a 4 and a 5. I can have a 4 and a 6. I can have a 5 and a 4.
But 3 and 6 is the first one, is the first one.
Right, I'm just writing down all my possible greater than 8 right now. Okay, so we're gonna have to take out some of these. 5 and a 5. 5 and a 6. Okay, and then I could have 6 and a 3, a 6 and a 4, a 6 and a 5, and a 6 and a 6. Okay? Yep.
How many do you have?
I need to find when spin 1 is intersected with spin 2. So I'm going to look at the 2s. There's no combinations with starting with a 2. So 2 is out. Okay? My other possibilities are 4 and 5. Right?
Yeah, but you can't have a
Yeah, because 4 is an even. And 4 plus 5 is 9. Okay? 4 and 6. 5 is not even, so I can't use that one. The first one has to be even. 6 and 3. 6 and 4. 6 and 5. And 6 and 6.
How many is that?
1, 2, 3, 4, 5, 6 of them total right there. Okay? Yes?
Does that have to be written like this on the, like, you know, spin one and spin two?
Does it have to be written just like this? Well, I just did that to help me think through.
Like where it has the squiggly line on the side?
Oh, no. Okay, so we want to find the probability of it being an even times the probability of the sum, I'm using my sigma notation for that, being greater than 8. So my probability of it being even was 3 out of 6, right? The probability of it being greater than 8, how many did we have? 10 out of what?
Wait, where'd you get 36 from?
Right here,
Where
3.
is that 3 coming from?
Because there's 2, 4, and 6.
Oh, so I
Yeah, but 2 doesn't count.
Yeah, well, it doesn't. I just was using that for later on because it doesn't add up to be greater than 8.
36. Is that okay?
Yep, 10 out of 36.
Where do you get 10 from? Oh, there's
Because we added up, there's 10 right here, right? 10, 3. Okay? And then it says, so if I were to multiply that together, I get 30 out of 216.
Where do you get 36 straight from?
36 is 6 times 6.
Why?
Because you have 6 possibilities on the first spin, and 6 times the 6 is the second spin. Okay? So if I multiply that all out, I get 30 out of 216. And I can reduce that,
15 over 108.
or even smaller, 5 over 36. Okay? Now, I want to see if that is the same thing as what I got here. How many did I get on this part right here? How many possibilities? 6 out of 36. That is not the same. So by doing this, I have proven that they are dependent events.
Wait. What's 6 over 36?
What we found when we found our intersection, spin 1 and spin 2, when they actually come out to be greater than 8, I found that there were 6 different ones. 1, 2, 3, 4, 5, 6. So if I were to ask you to show me that they're dependent, this is how you go about doing it.
So would P even, the probability of even, would that just be if
Yeah, you have just as many chances of winning on that last spin as you do, as you did before. So yes, this is independent, and you can just use a little bit of common sense for that. Okay?